Well, it must be true what they say. Time really does fly when you're having fun. We're already up to part 10, and we are ready for another Class B example. And I wasn't feeling all that creative, so I turned to ChatGPT, and I said, ChatGPT, give us a really hard subnetting question like we might see in CompTIA's Network Plus exam, and make it about subnetting a Class B address. And ChatGPT said, no problem, here you go. You are given the IP address 172.16.00/20 for your organization. How many subnets can you create? What is the subnet mask in dotted decimal notation? And what is the broadcast address for the first subnet? Some of you are looking at this and you can already do portions of it or all of it in your head. I know I can do one part of this in my head for sure, and that is there's /20 bits of subnetting. So that's 8 bits of subnetting for the first octet. That's 8 bits of subnetting for the second octet. That gives us 16. And then there's 4 more. So there are 4 bits used to create subnetworks in this example, and that would give us 2 raised to the 4 number of networks. So the number of networks we can create is going to be 16. As far as the dotted decimal notation of the subnet mask, I could do that in my head too. I'm going to need to write some stuff out for the broadcast address for the first subnet. Many of you can already do that in your head though. I'm just not that good. All right, so let's see how these would be worked out on scratch paper. Let's tackle what is the subnet mask in dotted decimal notation first. Here are those 4 bits in that third octet for the subnet mask. And notice if we're using those 4 bits, it's going to be 128 plus 64, that is 192, plus 32 is 224, plus 16 is 240. So our subnet mask in this case is going to be 255.255.240.0. Boy, isn't that easier to write in prefix notation with the /20? It sure is. All right, now that we've figured out that part of the question, we have the other part of the question, and that is how many subnetworks can we create? I already worked that out in my head. We are using 4 bits for the creation of these additional subnetworks. 2 raised to the 4 is 16, as we can see in our handy dandy conversion chart, so we can create 16 subnetworks. They didn't ask us about this, but how many hosts could we accommodate per subnetwork? Oh my gosh, an awful lot of them. There's 4 bits available for host addressing in this octet, and then there is 8 bits available in the last octet. That's 12 bits available for host addressing. That's an awful lot of hosts that you can accommodate per subnetwork. We would need a scientific or programmatic calculator to work that out. All right, what are the first 2 subnetworks? Because remember, the last question we need to answer is what is the broadcast address for the first subnetwork? So what I'm going to do to figure this out is my block size is 16. Yeah, my block size is 16. So my first network is going to be 172.16.00. My second network is going to be 172.16.16.0. So what is the broadcast address for that first network? It would be 172.16.15.255. That's right, we're going as close as we can possibly get to that next network. And that is the broadcast address for that first subnet. Well, thanks so much, ChatGPT, for giving us a nice challenge to work on here in our series on demystifying IPv4 networking, and I look forward to seeing you in our next episode. Thanks so much for joining me.